I'll be showing you how to solve number 8 of chapter 13 of the ACS study guide, which asks, what is the major product of this reaction? Now, looking at the reagents, we can see that this nitrogen will be reacting with the ketone and will be replacing the oxygen. Now, usually for these reactions, the nitrogen always loses one of its protons, and then depending on how many substituents are on it, it'll perform an enamine or an imine. An enamine would have 2 substituents, and imine would only have 1. So looking at how many substituents are up here, there's 2, so it'll perform an enamine. So let's just draw how it would look replacing the ketone. Now the thing is, now the nitrogen is positively charged because nitrogen prefers having 3 bonds and it has 4 right now. So what will happen is it'll stabilize by the alkene going to on the other side, so over here, because it'll be easier to deprotonate a proton from over here because it's not stabilized by the carbons over there. So that's why D would be our answer. It can be B because, again, positive charge, no. And also still 4, wait, that's 5. 1, 2, 3, 4. Actually, no, it's 5. 4. So it can't be that either. And then A, the oxygen leaves, deprotonates as well. The proton, no. So it can't be A either. Now the second question I have is, what is the major product of this reaction? It's another product prediction. So we have what almost looks like an acid anhydride, but it's not. It's not an aldol either. Anyways, so we know that the oxygens around are going to be very electronegative. So whichever proton, let's draw in all the protons. H here, H here, H here, here. Now let's look at the reagents we have. This is OCH, which is practically like saying OMe. This is a very strong base. So what this will do, it'll deprotonate the most acidic proton, which in this case would be this one because it's surrounded by a lot of oxygens. It's the most surrounded. So what happens first is it deprotonates that, leaving the electrons there. Therefore, this will have a negative charge. It'll be very nucleophilic. And then the second reagent, it's reacting with CHBr. Now, Br is a very good leaving group. It's electronegative, and so the carbon connected to that is sort of electrophilic. And so the electronegativity of the electrons will be attracted to the carbon, the methyl, and it'll bring it towards itself, and the Br would leave the group with the protons. And so what happens is the methyl will attach here. So based on the prediction we made, C would be the answer. It can't attach there because that's it's the second least acidic side over here. It wouldn't attach there. It wouldn't attach here either because that's almost just it is the least acidic side. And then it wouldn't attach here either because it's not an acid. It's actually a strong base.